So let's open PyCharm, for example. New project. Week 7. So this is the halfway till the end of classes. We have 14 weeks, so this is week 7. Week 7. I will open terminal, Python. And so let's create a list. For list is the array of objects of different types. So for example, I can create a list and include integers, include floats, include Boolean, include other types like strings, and it all will be valid in elements of our list. Type. If I print the type of this variable, oh, missing parentheses. So this is the type of this variable is list. You can access the elements of list by index, by slicing. So for example, a list with index -1 will return me the last element of my list. You can also um, uh, change the variables. So this is maybe the first data type of arrays, which are mutable. So you can change, for example, last element of a list and assign a new value, let's say B. And if I print again my list, the last variable will be changed. So the only problem with lists is that if you use them as parameter in your function, let's create another list, B, for example, B equals A. Oh, sorry, B equals a list. And my B should be the same as a list. Print B. But if I change now some elements in my list B, for example, I will change the second element to false. And if I print the list, original list, a list, the original list also will be changed. So this is the tricky thing with lists, because when you create a new variable, like I created B equals a variable of type list, it doesn't create a copy of this variable. It just uses the reference to the previous variable. So so if we change the one of these variables, the other one also will be changed. So this is a tricky part. Um, if you want to create a real copy of the list, you should use copy. So for example, if I create a variable b equals copy, I believe it will work, copy of a. Maybe it should be a dot copy. Oh, a list. Then it will create a copy of the variable. And if I print now, so this is a list. If I change now b variable, and print this variable b, and then print variable a list, now the original list won't be changed. But it's not the end of the story. Lists can contain lists as elements, like nested lists. And even if you use copy with nested lists, it won't work, unfortunately. So as I said, lists are tricky. Um, for example, okay, I don't want to spend time. So, but you, I think, understand. If I create a list as element of my list, and even though I use copy for a new variable, but if I change the nested list element, it will be changed in the original one. To create like the complete copy, there is function deep copy. But for deep copy, I believe you need to import the module copy, and then let's see. I I believe it's the module is called copy. Deep copy. Right. Um, yes, I believe you should import the module copy, and then you can use deep copy. So, okay, let's do an example. For example, let's create a list inside a list. So the element with index 2 will be again a list. So what? Oh, I'm using variable a list. So here is my new list with nested list. I create a copy of this list with a built-in method copy. And then I change a variable with index 2. And for example, I want to change the first element of this list by 5. Unfortunately, if I print the original list, this variable also will be changed. This was what I was talking about. If you want to completely separate these variables, you should use deep copy. Import copy package, and then if I create this variable b as copy dot deep copy of a list and change the first variable to, for example, 10, and print a list, finally it won't be changed. Okay, so these are lists. How to add elements to the list? It's interesting. You can use append method, for example, list dot append, and whatever variable or constant, let's say, um, just a string constant. This will be added to the end of the list. So your list will be extended. The other way to append this element was to create a list plus plus equal to. So if I print my list, I didn't expect do you see what happened? It added the string as individual elements. Actually, I would expect that it adds the entire string. Um, so it's called unpacking. Let's see. If I want to add so if I want to add just the string, I believe I should add a list plus this string. What? Oh, I see. Okay. The problem is that I added elements of different type. I added list and string. I can add only lists. So to fix that, I should create a list of this string, and then it will work. Let's see. And the same with the first example. Um, if I do instead of this syntax, I will add the list of one element, then it will add this as an element. Okay. So now I see my mistake in the first example. I just added to list another data type, a string, and it unpacked what it means. It created a list of individual elements of a string and added them to the list. So what's the difference between plus, equal, and the other way of adding lists? You can think that there is no difference, but there is. The first comment will create a new variable. So it will rewrite our variable in, and if we check the memory cell index, I believe it will be different. If we use this comment plus equal for lists, it won't change the variable. It will change it in what we call in place. It will just add the next element. So this syntax is equal to append. This syntax, in this case, we create a new variable. So How to remove elements from list? Let's talk about this. There are two pre-comments to remove elements. So one comment is pop. Pop will remove, without indexes, it will remove the last element. With index, it will remove the element by index. It will remove this element, but also it will return this value. So let's try this pop, a list dot pop. So if I print my list now, you won't see the last element. I gain 2, but it returned this last element. So it's sometimes useful. For example, you want to read something from list and remove this element. So you can use pop. With index, it will remove element, I believe, by index. Let's see. The first element is 1. So if I type 0, it returns the element with index 0. HTML. So the other way to remove elements is what's the other method? There is del, but also remove, I believe. Cedric, do you remember? Huh? Remove, yes. So the other way to remove is method remove. Remove. Um, by index, or let's see. So my first element now is 0.5. And it says is not in the list. Yeah. Okay, so the remove method removes by the value. And if I'm not mistaken, if there are several elements, it will remove the first one. But I'm not sure. So the other method to remove elements is del. Del, and here you remove kind of by both and value and index. A list with index. Oh, what's remaining? Okay, the next element will be list. So let's see. Yes, so the other way to remove with del command, and it will remove uh, like this by indicating the index of the list. Okay, so what can we do with the lists? Let's talk about the application. And the first application will be sorting. Oh, let's say, and maybe I can just write on the screen. Will be more visible. So let's say we have a sequence of numbers. I don't know, just arbitrary numbers. 7, 5, 11, 2, 0, 8. And we want to sort them. from the smallest to the greatest or other way. So, do you know any algorithms for sorting um, let's say uh, if you play the cards, sometimes you want to order your cards by the um, value. So what are you usually doing? You look at your cards and maybe you take the smallest one and move to the first position. Then you look at the next smallest value and move to the second position. Did did you do sometimes with this with cards? So this way of sorting is called insertion sort. So insertion sort, there are many algorithms for sorting. The first algorithm that we will cover in this class today is insertion sort. Insertion sort. And it works exactly as I told you uh, a moment ago. Well, actually, it doesn't work like this. The method that I explained is called bubble sort. It's kind of find the smallest element and move this upward bubble, like bubble in the liquid. Insertion sort works a little bit different. So we look at well, we can't compare the first element, so we look at the second element first. And if the second element is smaller than the previous one, we flip them. So we flip them, and now we will have this sequence of numbers. Then we look at the third element. If the third element is smaller, we flip this element with the previous one. But in this case, it's greater. So we leave this element as is. And on the next step, we look at the next element. So 5, 7, 11, 2, 0, 8. 2 is smaller than 11, so we will flip this element with the previous one. But after flipping, 2 will be smaller than also the previous one. So we will continue this flip. But 2 will be also smaller than 5. So we also will flip 2 with 5. As the result, we will have 2, 5, 7, and 11 in place of 2. So it's kind of when we go backwards, we flip until our element is greater than the next one. Okay, and because all the previous elements actually were in order, on the next step we look at the element with the next index. And as you can see, 0 is smaller than 11, 7, 5, 2. So we will do flips with every previous element. And as the result, we will have 0. These elements will be shifted by 1, 2, 5, 7, 11, 8. So we flip this, 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 and this. And finally, we have the last index, 8. 8 is smaller than 11. So we flip with 11 and we stop here because 8 will be greater than the next element. Now we will write the code for this insertion sort using the lists. Okay, I hope you understand the idea of the algorithm. Now let's implement this algorithm. I will leave maybe for now this as example, even though it's overlays with code. So and we will use the data type lists to store our values. I don't know. We can do the user's input. Let's see. For now, I will just hard code the variable. Then we will do a user input, a list. Or maybe we can do the user input from the beginning. So a list equals input and print a list. Oh, where is my? I don't see. Oh, where is? Okay. I should print maybe some text input because otherwise I don't see the command line. So okay, let's write down our list with. So if you type the elements with spaces, it will read this one by one and create the list of these elements. Okay, we have a list. Now we should write the function sort, define insertion sort, which takes as input our list. Oh, and it's tricky because if my function uses the variable a list as input, and I will change this, I will sort this list inside this function, the original list also will be changed. But it's fine because so it means that we will create the function in place. If I don't want to create this in place, I should in the next line create a new variable with deep copy of my input and then work with new variable. Does it make sense? So I will just write this as a comment. If I don't want to change my original list, I can write. In this case, we don't have nested lists, so it's fine to use just copy. But if it contains nested lists, we should use deep copy. A list dot Okay. Actually, I can uncomment this. It's fine. So then what I will do next, I will go through all the indexes of my list and do the flips if they are needed. So for uh, index I, we can use IDX in range maybe I can clear up a little bit. So what should I write inside the range? If I want to go through all the indices of my list, how to get all the indices from 0 to the length minus 1. Oh, maybe you don't know. We can apply, yep. Yeah, I didn't mention this. We can apply len as for strings, and len returns the length of the list. Yes, len of our list. And here, we should do the flip, but I will write a separate function for flip just to make this code a little, maybe a bit more clear. So I will use the function that I will define later. Swap. Swap. Wait a second. Oh, how to spell swap? Huh? Oh, but why it's red. It's red because I didn't define this. Sorry. I was thinking that it's the grammatical error, but it's the a variable, a name error. Swap, and the input will be uh, the the first part of the list. So new list, and I take slice. Um, and the current variable. Oh, wait a second, or maybe I should pass the entire list. Yeah, it's because of this reference instead of copying of the list, it's better to pass the entire list, and then my function will change this list in place. Because if I take slice, it will create a copy. But if I don't create a slice, it will change the list, like even though outside my function, but it will be changed in global. So I will use just a list and the current value, new list. So every time if you take slice, it will create a copy. But if you don't take slice, it will create a reference to this object. New list with index I. Okay, so let's now write this function swap. Uh, of, well,
If you use slice, what does it create?
Copy. So I don't know, maybe because you were late, you didn't hear the list. If we assign a new list, for example, new variable to a list, it it's the same object. So it doesn't change the variable. It doesn't create a new variable in the computer memory. So if we change the second object, the first also will be changed, which we call in place operation. But if you take a slice of list, it will be a new variable. Or if you create a copy of list, it will be a new variable. So that's why here, for example, in the first line, I created a copy. If I don't create copy, I will change the input variable as well. So swap, there was a list. Now I will create a B list because I don't want to use just list name because list is a built-in type. And if I use the built-in type or variable, it will rewrite and so don't use the built-in types as the variable names. List, and takes also the value. And wait a second. No, maybe it's better to take the slice because let's see. Or I also will need the information about the index. Let's also add information about the index. Oh, actually, it's IDX. Okay. List element. Actually, it's enough just to have the index, because then I can access to the element to the value by index. Okay. Okay. So now what I will do here, I need to compare my element with the previous one. Actually, here range, I should start from 1, so I don't need to check if my index is greater than 1, greater than 0. So if my B list of IDX is smaller than my list of IDX minus 1 of the previous element, I should swap them. And here is the tricky part. You can use the temporal variable. You can create a temporal, I will write this as a comment, temporary variable with, for example, current value of list, then the current value of list, assign the value of the previous element, and then change the previous element with the value that was saved. But in Python, we can do this in one line, like the previous element and the next element equal to um, okay. So if I want to create a new line, you can use this syntax to use the backslash and make a little bit space from the previous attempt. So this one line syntax should work, but in other languages, you typically create this like additional variable. Maybe you've heard this example, how to, if you have three cups, and in two cups you have, for example, different drinks, how to change these drinks in these two cups. You should first empty one cup into the third one, then fill the first cup with the liquid from the second cup, and then use the liquid from the third cup to fill the second cup. So this is exactly what this code does. It uses the additional third variable. This syntax in Python does exactly the same under the hood, but for us it's easier to use just one line. But it's implemented exactly with using additional variable. So we flipped one time, but now we should also check like the for example, if it was 2, we flip with 11, but then we should also check if 2 is greater or less than 11. So maybe we should write kind of while loop or for loop. So let's do while loop. While index is greater than 0. So let's add so if before if we will add a while loop. If idx is the input for our function, so it's defined is greater than 0. And after changing this wait a second. So after swapping, we will decrease index by 1. idx decrease by 1. But what happens if our element is actually greater than the previous one? Should we continue the while loop? Or maybe we can stop it. So how to stop the while loop? Yes, you can just say that. Yes. So let's add also statement else, and in else we will do break. Because it doesn't make sense to compare the element with the previous ones if it's greater than the last one. So, I mean, it doesn't hurt, but it will save the operations. So if else break. Okay, let's see if our code works. So I will call, I should also do the return statement. So in swap, I don't use a return statement because it's in place. It will change my list in place. Does it make sense? I could do return and change and create a copy, but I don't want to. But in the insertion sort, because I create a copy, I should do a return statement. Actually, if I want to sort my list in place and I don't create a copy, let's comment this line for now without copy. And then it should change my list in place. Let's see if it works. Oh my gosh, there is a new list. I should copy. I should comment a copy. Okay. Okay, so two functions without return statement, and still we will get something. So let's print instead of list. Yeah, so first I will call my function insertion sort. It doesn't make sense to print because without return statement, it will return none. But I will apply this function and I will print the original list and I believe it will be sorted. Let's check it out. Oh my gosh, missing colon. Okay, let's try again. 7, 5, 11, 208. String doesn't. Oh, okay. Our elements are strings. I want to cast them into integers. Okay. So when I read the list, where is it? It's here. I should cast. Let's see if I can just cast it here. Int. I'm not sure because it will read element and element by element, but let's see if it works. Hmm. Yeah, it didn't work because we have a list. So what can we do here? So it reads a string. We can split the string by space, split. After split, it will create or maybe we can do, Cedric, maybe I can use the while end of string and read element by element and cast into integer. The other way is to read the string, split the string into elements and cast every element into integer. Huh? What should work? No, but the type will be string. I want integer.
Yeah, because usually every function or every function compared to everything. 1 integer. 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 1 But like you're taking the string from the list
Yes.
and then converting that string into an
Yes.
sections.
Oh, you mean to convert inside insertion sort?
That's all.
No, but I mean, I want just to read the list of integers. So I believe one thing is to read the, so, okay, one more operation with strings, which is called um, list comprehension. So I can create a list of elements of another list. So here I can do int of an element for element in this list. So this is called list comprehension. It creates a list from another list. Here, my E goes through all the elements of the list, and then each element is casted into integer, and then I will have a list. So I will print how it works. For example, 7, 5, 11. And now I will have the list of integers instead of string. So this is called list comprehension. You iterate in over list and create another list. I mean, you could do this using for loop. For E in list and create empty list and append to the end. But I believe this is more elegant way. Okay, now let's try with list of integers. Our function. Okay, something worked, but it's not sorted. So let's think about our errors. I believe we don't need break. I mean, we will do break now for class, but we don't need break in the function because so if let's see. So what happened? 5 was changed with 7. So the first step worked. But the second didn't work. So yep.
Line 15. You have index minus equals index.
I should add. Yes, thank you. Okay, let's see if this fixes the problem. 7, 5, 11, 2, oh. Wow, thank you. It worked. Okay, now last thing before we do a small break. What if I don't want to change my list in place? So I just uncomment this copy. I will create a copy and I will add the return statement. Return, I said new list. And I should print then, I will assign a variable new list to my function or sorted list. Oh, actually, I can just print this. I can just print, because now this function has return state. And I will have sorted list and the original list unchanged. Okay, let's do a break now and 5 minutes. And we will talk about tuples and searching in the next part of the class. Okay, let's continue. And next topic for today. 1 second, I will resume recording. So the next topic for today is searching. So now, how to, well, you can use the built-in functions for searching, but um, you also should know how different searching algorithms work. So we had the sequence, for example, 7, 5, 0, 8, and so on. Let's say we had a list. And now we ask a question, if the element, for example, 2 is in our list, and if it is in our list, what is the index of this element? Well, and you can think about the simplest algorithm, how to answer the question about if the element is in our list and return its index. So what would be the easiest algorithm? If I want to check if element 2 is contained in this list. Yes? So,
Just move to the list and then return, just move to the list and then return the index, you see it, don't return the index.
what? What will be the algorithm?
I mean, just do it one.
Yeah, so just iterate through.
Yeah.
Yes, the first idea that comes in our mind, just to iterate through the entire list and compare each element with number 2, and if we don't find this element in our list, then return none, for example. But if, for example, we will look for element 0, when we find this element 0, we will return the index. What is the time complexity of this algorithm? How many operations in the worst case, for example, if 2 isn't in our list, how many operations should we do, or iterations? If n is the number of elements in our list, then time complexity will be also n, because we should iterate through the entire list to understand if this element is in our list or not. So, for example, but what about 7? If I want to find the element 7 in my list, how many operations will I do if I iterate through list? Just 1. So the worst case for this algorithm will be n. The best case will be just 1 iteration. So let's talk about better algorithm, which is called binary search, or divide and conquer also. Maybe you've heard about this approach. Binary search. Divide The general name of this class of algorithms is called divide and conquer. Uh, so yes, the idea of this algorithm is to split our list into two parts. And so in this case, I have even number or odd number or even number of elements. So I can split my list into equal parts. So for example, if I use the floor division, length of my list divided by 2, what will be the index of the middle? Well, middle, it's hard to say what is middle, 5 or 0. What will be the index of this element which we'll use as a splitting of our list? So in this case, len is equal to what? What is the length? What? What? No, I mean the length before division. 4. The len is 4, even though the last index has index 3. And divided by 2, it will be 2. So what will be the index of the splitting element in my case? It will be 2. So I will divide by 0. I will split by 0 in this case. So I will split this list into... Oh, okay. I didn't say that the list should be sorted. My bad. So first, we should sort the list. That's why we started with sorting today. So first we sort in the decreasing order, like this. So the first step is sort. After we sort, we split our list into halves. So the split will be by index 7, by index 2, element 7. And then we will look for our element either in the first half or in the second half. So for example, if I want to find number 2, well, let's maybe start with the existing number. If I want to find number 0, what will be the process? So I sort my list, then I compare, then I split the list into 2 smaller lists, and then I compare the elements that I'm looking for, 0, with what? What do you think? With which element I will compare the searching element? We know only one element for now, the element which we used for splitting. So I will compare my 0 with 7. If 0 is smaller than 7, then I will continue searching in the smaller part, in the left. If my element of interest is greater than 7, I will continue searching in the right hand part. But I will reduce my task to the searching in twice smaller lists. That's why it's called binary search or divide and conquer. We divide our job in halves. So let's talk about 0. So because 0 is smaller than 7, my next list of interest will be the left hand side, the left list. So what's the next step? What is the length of this list? 2, because 2 elements. Then we divide 2 by 2, it will be 1. We will find the index of the middle element. So the index of the middle element will be 1, and we split this list into 2 halves, from 0 to 1 and from 1 to the end. So now we compare 0 with what? Which element was the middle element? Which element we used for splitting? 5. So now we compare 0 with 5. Because 0 is smaller than 5, we will continue searching our left list. And finally, actually, here is the base case. I don't know. We can check if the size of the list is 1, and we can stop our process of splitting. Or, yep,
It's the number and find for 0.
yes.
So the base case would be that whatever area you go to, whatever the middle element is equals to whatever element we're trying to find, that is the base case. So
Yeah, but I mean, now I have the list of one element.
yeah, so
So should I continue this division process?
no, because what happens now is you check the middle element of that list, which is 0.
Yeah, but still, if to find the middle element, I should divide length by 2. This is my question. Should I? Maybe it doesn't hurt. So if I divide length by 2, the index will be 0. So, and then I can create actually, and I can create a left list.
For like the list of just elements of you wouldn't create a left list.
Yeah.
You just check them. You could check it. Element is equals to whatever element you can find. If it's not, make 2 list. If it is,
So, okay, I believe I will get what I will get. I will get so I will split this into empty list and 0. And the index of the right list will be um, greater or equal. So now the smallest index won't be smaller than the index of the right list. So I believe this will be the base case when the index of the smallest element here is not smaller than the index of the larger list. So this we will stop here. And okay, so this is the process. Let's try to code this now. And by the way, we can look at the code. Code is on the Rob page for the course. So binary search binary search. So the input is the sorted list, sorted array. Let's just hard code for now. Or maybe we will use input a list. Um, I will use list comprehension. Actually, for searching, they shouldn't be integers. The list can be of, let's see. But if we want to sort the list, it will be hard to sort the strings. Okay, let's do integers of the character for character in input. First, I want to check that my function, my input is working. It doesn't work. So I should create input. And then for input. Oh, sorry, I should split. Okay. In input, and I should split. So now let's write the function for binary search. Because we will split our list into halves, I will need two extra parameters. The starting index and the ending index for searching, because these indexes can be different than 0 and n minus 1. They can be from 0 to the middle element, from middle element to the end, and so on. So define binary search of a list but also the element that we want to detect, and the beginning index and the ending index. Start and index end. And as you guess, it will be a recursive function. So I don't change elements in my list, so I don't care about creating a copy of the list, because I won't change, I will just search in this list. So while I believe the condition will be the smallest index of the previous element should be smaller than the element, the index of the right-hand side of our split. So the middle element IDX middle will be or maybe let's include this in while loop. While see while IDX and IDX and is greater than IDX start. So if we will have a list of one element, actually this condition won't be satisfied. In if we have list of one element, they will coincide. Then we create the calculate the index, middle index. Um, so in the beginning, it should be just length of our list divided by 2. Maybe I should calculate the first middle index before the loop function. Oops. Length of a list divided by 2. So the next step, I should compare element if my element is smaller, I don't know, smaller or equal to, let's do smaller than a list with index middle. I will continue search in the left list. So my IDX start won't be changed. But my IDX left end IDX end will be the middle index minus 1. Otherwise, I will continue searching in the right list. So else my last index won't be changed, but my first index IDX start will be equal to the middle index. Does it make sense? And after that, I will continue searching in I will continue searching in these halves. So maybe I should just call recursively this function, and I need a base case. So what will be the base case? So what I want to do here, I want just to call my function again, binary search with my array, which is a list with element, but the beginning index will be unchanged, index start. And the last index will be middle -1. And the same I will do in else. So I will call my function binary search from a list, from element with from index middle to index end. So it looks good, but I need the base case. So when we will stop? Um, I believe, let's see. I believe we will stop if our element coincides with a list of index middle. Let's see. While let's do return. Return element coincides with a list of index middle. And in the beginning, I'm not sure, maybe I should use, instead of len of list, I should use index and minus index start. IDX and minus IDX start. Let's see if it's working. So, oh, but I didn't call the function. So I should call a function binary search of list. Let's find element 3, index start 0, index end, length of my list. I didn't close parentheses. Okay. It looks like I don't have the base case. Okay. Well, maybe it should be not while, it should be if, and else. So if I will call my function, and in the base case, I will return, let's see if it helps. No, it's still not working. Okay, let's look at the code in our web page to compare. Okay, so the base statement is the same if start is greater than end. Oh, okay. The middle index is, I should take the average instead of subtraction. So, okay. Let's see if it helps. Okay, it says none, so but because I'm looking for index for element 3, actually it should return something. Okay, but at least it doesn't enter the infinite loop. Okay, what else should I change? So we calculate the value of the middle element. Then we compare if. Okay, maybe this is missing in my code. Um, so if our element equals to, bless you, if equals to a list with middle index, we will return true. Or actually, we can return the index itself. But for now, let's return true. Okay, and it worked. So this is the binary search. Now, the last thing about complexity, and we're done. Oh, how many operations should we perform in binary search? So we start with a list of size n. Then we split this list into two halves, each of size n over 2. Then our element can be in one of these halves. Then we split this each half also in halves. So it will be 1 over 2 squared. And what will be the end? What will be the last line of this? This is called binary tree. The last line will be, so you can see that each line has the sublists of size n over 2 power k. And the last line will be when we have just one element. So when the size equals 1. Does it make sense? Can you solve this equation with respect to k? So if we multiply, we will get, so k equals log base 2 of n. Log base 2 of n. And this is actually the number of lines or the number of splits. What is greater, log of n or log of x or x? Do you remember these functions? I will just show you now. So the log is smaller than linear function. So that's why we actually covered this binary search, because it works faster than just a linear search, just going through iterating through the entire sequence. Okay, now let's take the quiz. And sorry, I told you last week that this week will be very intense, a lot of information. Weeks quiz 7. Oh, I didn't even talk about tuples. Well, tuples actually are the same as lists, but they are immutable. You can't change the value. You can change the values in tuples. And the difference is that for tuples, we are using parentheses instead of brackets. So yeah, if you will see a question, this means tuple, this means list. The first is mutable. The second is immutable.